technical hiccups. Roger, I don't see the attendee option, so maybe I'll leave that to you to.
Sure.
I do see the Q&A, but I don't see the attendee thing.
Oh, the inviters, the participants are coming in, yeah.
Yeah.
There are 22 attendees. Okay, I've got them.
Okay. Hey, welcome those who have joined. I was watching a show the other day with, I don't know if it was on Marvel or what it was, with my kids, and there was a comment that you're either early or you're late. There's no such thing as on time. Unfortunately, with this, you weren't let in until you're actually at the point where you're late. So that's okay. And maybe we'll wait for a few more people that might be late. We'll get started in a couple of minutes. I always cringe at, benefiting the people that are late, and those that are on time or early get punished, but that's how it goes, I guess. Okay, now I see participants. Aha. And listen, if you have questions, please use the Q&A function. You click on that box at the top and you can type out your questions. I guess because there's a lot of people that are registered for attend, the organizers have got your microphone muted, so you won't be able to speak. Just Roger and I will be able to speak. So please use the Q&A function. You could also use the chat, but I'm told it's easier for us to monitor the Q&A than the chat. So Roger, if you want to answer the questions by typing back, that's fine. Or I'm happy to take questions if you want to field them to me, or you feel this is, maybe something that everyone would benefit by.
Yeah, by all means, if I get any questions that I think that are related to the presentation, I'll bring it to your attention.
Perfect. So you can see on the slide, I'm Peter Saunders. My title is Director of Building Science and Technical Services. I've been with the company for a few decades now. The first 20 years I spent in the field as a technical services rep, being on job sites, troubleshooting, hands-on training, involved with R&D, helping develop new products. And about a little over a decade ago, I had the opportunity to join the management side, and that's where I've been ever since. Unfortunately, for the past year, I've been pretty much stuck in my basement, like a lot of you have, and we're trying to get over it, but it still presents some challenges. So I brought my colleague, Roger Ollie. He's here to help, and should the internet fail on me, Roger will jump in and take over. Roger, you'll have to have your own version of the presentation. I don't know that you'll be able to control mine. I'm not sure how that'll work. Hopefully we won't have those technical hiccups. Roger, very knowledgeable in these products as well. So, again, we'll work together on this. So please ask your questions as we go through. Sometimes it's easier to address while we're on that particular slide than waiting till the end. I'm happy to do that. If we get overwhelmed with questions, we might hold them off, or perhaps if it's better covered in a future slide, deal with it then. So if I can get my slide to advance, we'll start going. There we go. So this is an AIA formatted presentation, hence the groovy 4x3 format rather than the more modern 16:9. Believe it or not, that is a requirement of the American Institute of Architecture. That is part of their format. So we'll jump into the AIA format, just sort of a brief introduction about what we do at Henry. And as you can see here, we describe it as managing the flow of air, water, vapor, and energy through a building or structure from foundation to roof. Today, we're going to talk about pre-applied waterproofing, so that may include under the foundation, depending on the type of structure as well. What we do is we're a manufacturer, again, of air barrier systems, both sheet applied and fluid applied, both vapor permeable and impermeable, of waterproofing systems, whether it's self-adhered, hot fluid applied, cold fluid applied, polyurethane methacrylates, or pre-applied waterproofing is something we've added to our portfolio of recent times. And perhaps if we have time at the end, we'll speak a little bit about that as well. And last but not least, we are also a manufacturer of roofing systems, vegetated roofing systems, protected membrane roofing systems, roofing underlayment, maintenance coatings, modified bitumen systems, cool roof reflective coatings. All of those things are manufactured by Henry Company in North America at various plants scattered throughout North America. And again, as I mentioned, this is EIA formatted. If you need continuing education credits, be it OAA or this is actually registered also with the AIBC. We're working on others, CAGBC and IBEC and so on. All of those are not in play now, but I'm sure this could be used as self-directed type credits or structured credits, as is described by the OAA, as it is already approved by the AIA. So what we're going to learn today, we're going to talk about industry definitions of pre-applied waterproofing. What are pre-applied waterproofing systems? We'll talk about, what to look for in installation and what critical details should be of concern. And lastly, we'll talk about typical warranty requirements from various manufacturers, as well as quality control on the job site. So we'll start with definitions. And really this graphic is here to describe what is waterproofing. So really there's two main types of waterproofing. If you look at on the left of the screen, you'll see positive waterproofing, where the water pressure is against the structure, pushing that membrane against the structure, be it on a wall or underneath a slab. Conversely, negative waterproofing is installed on the interior and the water pressure is trying to push the membrane off of the structure or detach it from the structure. So within positive waterproofing, it can be applied before the structure is in place, hence the term pre-applied, or you may hear other terms like blindside, tanking, zero lot line. Roger, maybe, there's probably several other terms I've missed. A term came to mind, but it just slipped my mind. It's commonly used out west. It'll come back to me. But anyway, positive waterproofing, again, pressure pushing the membrane against the structure, negative waterproofing pushing it off of the structure. The positive side to positive waterproofing is you're keeping the structure dry, whereas negative side waterproofing, it may be keeping water out of the structure, but it's not protecting the structure. In other words, water is getting into that wall or slab and possibly resulting in some deterioration. So on this slide, we talk about pre-applied. If you look at the detail on the left, you can see the supportive excavation system. You've got some steel soldier piles, wood lagging, and then membrane is applied to that. Sometimes a drainage board will be used if it's attached to a dewatering system. If not, it really should be applied directly to that supportive excavation, and then the concrete walls get cast against it. So it is still positive side waterproofing. The difference between pre-applied and post-applied is the sequence of construction. So with pre-applied, it's applied before the concrete is cast. With post-applied, the concrete is cast and the membrane applied to it. Where one is used over the other, well, there's a number of reasons. Typically with pre-applied, it's where land value is very high and the owner or developer is trying to maximize the use of that land. So they're going right to the edge of the property. In other words, they don't have space for an open cut excavation to allow them to cast foundation walls and waterproof and then backfill. It is right up against the property line. So within pre-applied waterproofing, there are really two main types. First, we'll talk about passive waterproofing. So a passive waterproofing membrane is a membrane which is waterproof all the time. It doesn't need to react or be affected by water in order for it to be waterproof. It repels water immediately The downside is some of these systems can be trickier to apply in colder weather. Most have precautions that can be taken to push that envelope. They're also characterized by very high puncture resistance. And that's how they resist water from getting through, right? They're not punctured by the concrete pour or something related to the excavation. Again, very high puncture resistance as well as very high chemical resistance. So if you have saline, salt water, soil contaminants rather, other chemicals that may be in the soil may affect some types of waterproofing. A lot of the pre-applied waterproofing are very resistant to those types of chemicals. So if you look at this graphic, we show the soil and the pressure of water against the membrane. In this case, it's showing a polypropylene membrane with a geotextile fleece bonded to the membrane, and then the concrete gets cast against it. So with this type of waterproofing, the concrete grabs that geotextile fleece as well as reacts with the chemical adhesive that's described here in order to form a bond. So that's how the concrete bonds to the membrane. Unlike post-applied, you're bonding membrane to the concrete. So really what you're doing is using concrete as an adhesive. And it actually is a fairly wonderful adhesive if it's treated properly. The other main type of pre-applied waterproofing is what's referred to as active waterproofing. So it will react with water and cause it to swell. And in that way, it will resist water from infiltrating. So it may not be waterproof immediately, but on swelling, it can seal itself together. It can seal around fasteners. It can seal around minor damage in order for it to perform as waterproofing. What is important with this type of system is you need to be able to control the swelling. And the way that it is controlled, it's installed in a confined space. One of the negative sides to this type of waterproofing is should the supportive excavation deteriorate over time, or should the soil get displaced or washed away, the membrane cannot swell infinitely, and eventually it would swell so much that it allows water to infiltrate. So it's important that it is restricted in order for it to perform. Here we'll talk about mechanical bond and adhesive or chemical bond. And again, waterproofing membranes for pre-applied are typically characterized by one or the other. And there are some which we refer to as hybrid technologies that actually perform both. So mechanical bond is when the concrete, the fresh concrete is grabbing that surface, often a geotextile, a fabric, and it grabs that surface, that fabric, in order to hold the waterproofing system in place. We say here not as susceptible to dirt and debris, although it still needs to be reasonably clean in order for the concrete to bond. Because we're bonding only to the geotextile and not waterproofing itself, it can allow for what's referred to as lateral water migration. And that is if water gets past that core and gets into the geotextile, it can easily travel till it finds a way inside the building, typically at a penetration, a crack, or some sort of breach in the concrete. Whereas a chemical bond or adhesive bond is a bond between the adhesive and the concrete. So the concrete chemicals and the heat of hydration from the concrete react with that adhesive to form a bond. This type of system does limit lateral water migration because the concrete is bonded to the waterproofing. Therefore, if it is penetrated or punctured, water cannot travel easily to find its way inside the building. Again, it needs to be reasonably clean in order to perform. So these membranes, if they got dirty before the concrete pour, if there's a lot of job site washout or mud somehow became attached to it, it would need to be cleaned prior to waterproof. The third type is what we refer to as hybrid technology. So it's a combination of mechanical bond and adhesive or chemical bond in order for that membrane to perform, sort of giving you the best of both worlds. So there are systems out there that do, one or the other, or some do both. Is really the bottom line here. So here's a little video. I hope it's showing well, showing a ideal job site condition, we've got our excavation. They've installed the wood lagging and drainage board, followed by the membrane. This is showing a tape seam type membrane. So the joints are treated, the waterproofing is in place, the reinforcing steel and concrete is cast, water stops are put in the hole joints in the concrete, and there we have our almost perfect structure with very few penetrations. Again, this is ideal. We'll talk about some things that are maybe less ideal as we go through. So again, this graphic to help you understand how this is coming together. So we've got our soil, our supportive excavation behind it. We've got the membrane installed. And if there's a breach in the membrane, if it is well bonded to the concrete, water cannot travel laterally. If it's only a mechanical bond, water could travel quite readily to find its way to cracks and find its way inside the building. So, you know, depending on the hydrostatic pressure, you know, in other words, whether this is drained and dewatered or not, hydrostatic pressure will certainly find its way inside. As Roger once said, water is very patient. You know, it's got all the time in the world. It will travel till it finds a way in, or it will be kept out by a perfect membrane installation. Pre-applied waterproofing can also be used in a horizontal application. So here you can see a tunnel type waterproofing where they've turned up the vertical and now they're lining up the sheet and getting ready to detail the laps. In the photo on the left, you see a sheet piling system and a cement board has been attached to the wall to provide a good surface for the type of membrane that's being used here. So this type of membrane in this case needs a flat or planar type surface in order for it to perform. Some systems don't require a mud slab or a slurry slab, as you see in the photo on the left. Some systems can be applied directly to compacted soil or you know, reasonably smooth granular without sharp aggregate that may try to poke through. As far as vertical applications, you know, here we show rebar supports have been placed. There's a cone that covers the waterproofing, really quite a nice system here. It protects the waterproofing detail from being damaged by that concrete pour. Depending on the resolution you're receiving, this graphic may not be so clear, so I'll explain it. These anchors are supporting the rebar, vertical rebar and horizontal rebar. You know, again, the membrane forming one side of the form and the forming will be placed on the other side after the rebar installation is complete and then concrete cast in. So again, the term pre-applied, applied, waterproofing applied in advance or previous to the concrete pour. Another common thing you'll see in high-rise building is what is called an elevator pit. And, you know, typically the lowest point in the excavation, so something that's most subject to the highest level of hydrostatic head, should it be that type of site. Something to look for in a membrane to be used for elevator pits is, does it bond quickly to the concrete so that these forms can be removed and production can carry on the job site. If you talk to a developer or general contractor, this is very important to them because, you know, this is one of the first things that gets cast on the site and it's holding up the rest of the project. So the sooner they can release those forms and move on, their better chance of staying on schedule right at early stages in the project. This graphic as well shows, you know, a smaller pit where they were able to use wide sheets of membrane and keep the principal laps outside of that low point, outside of that elevator pit. And if you look at this graphic as well, these squiggly lines you see here are actually rebar supports, or what we often refer to in North America as chairs. This is not like a chair type configuration, but this is a support to keep the rebar and keep it up and keep that proper concrete cover. Accessories to the system, you know, depending on the type of system, you'll have tapes. Here's an example of a two-sided or a single-sided tape that doesn't display as well. A drainage board where, again, the system is attached to a dewatering system, a fluid applied or liquid membrane to seal around projections, and water stops used within the concrete pour, right? So it's not necessarily part of the pre-applied assembly, but it's a part of the waterproofing system. Water stops can be used as a secondary or last line of defense against water infiltration. It's typically used at penetrations, cold joints, anywhere where cracks will develop in concrete is where they're used. Just having a little pause for my tea. Thank you for your patience. So as far as tape seams is what we're showing here, a type of system that uses a tape seam. In this case, it's a double-sided adhesive, so it adheres the bottom sheet as well as the top. The other alternative is a top over tape, so it's a wider tape that spans over the lap in the waterproofing membrane. And this would typically have a surface to receive concrete to allow the concrete to bond with it. So a couple of different options shown there. And then the fluid applied, again, being used to detail around penetrations. It's likely this was a pile cap and it's a rough surface. So rather than membrane, Roger, have there been any questions so far?
No, there haven't been any questions yet, Peter, but your last slide came in a bit garbled. I'm not sure the participants were able to fully understand it. And I think your video may have also frozen up.
Okay, should I back up one?
Yes.
Yeah, sorry, you were a bit garbled for me there as well. Could you repeat that?
Yes, start from that slide if you can. Can you hear us? Just a question to the panelists. Are you hearing us okay?
Hey there, this is a webinar support. Yeah, it looks like Peter's just having some internet issues there. So stand by while we just give him a moment to sort that out.
Yeah, I lost you back.
Peter, you might want to just leave the webinar and just come back in, try a refresh.
I don't know what happened. Okay. Bear with me. Maybe take a quick tea break if needed. You see my screen now?
Yeah, it's coming back, and it sounds like your sound's improving as well. I think your connection's come back. We'll give it a second there. Yeah, I think we've just got your Wi-Fi is slowing us down a little bit.
Okay, so sorry, Kyle. I'll go back to share screen.
No problem, Peter. I've got a suggestion. If you just turn off your camera and just go to your microphone, it might just be a little bit sharper without the video coming through.
The Merkley screen.
Yep, we can see the Merkley screen there.
Okay, somehow my PowerPoint closed. Oh, it's Monday. Bear with me 1 second.
Stand by, audience. Thanks for your patience.
The slide I was on. Do you see my screen? No.
Yes, we can see your screen,
You've seen
Peter.
the Merkley screen. Kyle, could you share?
No, Peter. We can see the slides currently.
Okay, so
it looks like it's presenter mode. We can see the notes. Did we lose you, Peter?
Oh. Okay. Let me stop share. No, I'm still here. I just thought.
Oh, no, you're good. Yeah, you're good.
Okay. Okay, sorry about that. And Roger, this was the slide you were saying I came in a bit garbled for a minute there. So let me just repeat this slide again. This is really trying to show, seam treatment in the field. So some laps may be treated with a double-sided tape. Some membranes will have that already installed, but when we cut across the membrane, let's call it an end lap or a T-joint, it won't have a pre-applied tape. And this is where this over-the-top tape is used. So two options there. Kyle, am I sounding good now?
Yep, improved for sure. Thank you for that.
You're fine, Peter.
Okay. Yeah, the wonders of the internet. I'm not sure why this is happening. I know the government's spending a fortune. I just saw on the news this morning, Quebec's spending almost $1 billion on improving internet. So those of you on the other side of the river, you may be getting some help soon, I guess. All right, so we spoke about this briefly. I think this is when my connection started to crap out before. Showing pre-applied, you've got the sheet membrane installed and then the fluid applied, sealed around the top of the pile cap, and then the concrete column in place as well. I think I've got a better slide of that coming up, so we'll speak to that as well. Where water stops are used are in between concrete pours. So here's a water stop. This black line is the water stop. It's been installed, and then the next slab will be cast here. Water stops are also used around pipe penetrations. You see a gasket type seal here so that when the concrete is cast, it will grab around it. They can be bituminous, they can be swellable, non-swellable. This one looks like it may be a rubber type. There's all sorts of water stops out there. Swellable, hydrophilic, in other words, water liking, so it reacts with water to swell and affect that seal. A lot of people think, hey, that's the greatest thing. Dark downside swellable water stops. At Heavy Company, we manufacture both, so I can speak to both from experience. Swellable, the thought is, well, it's going to swell and it's going to fill every little crack and crevice. If the concrete's not even there or not fully consolidated, it will stop that leak. However, if it's too close to the edge of the concrete, that swelling can cause the concrete to pop, fall. So typically they'll insist on, we say, at least 2 inches of cover, concrete cover, ideally even 75 millimeters of cover, just so that it's not close to that edge. Concrete is really strong in compression, but weak in tension, and tension is where the popping will happen. The other type is hydrophobic or non-swelling type. And the advantage there is that should it get wet or
Hey there, everyone. This is Kyle with technical support. I sensed that we were losing his connection there, and it went right out.
Yeah.
Thanks,
Kyle,
Roger.
I can take over from here if you like. If you'd like to.
Sure, I appreciate it. He may join us again if he gets his connection back up, but I'll let you take the floor, Roger. Thank you.
Okay. How do I present here now?
You should be able to use the screen share option, either at the top or bottom of your screen, depending on where your Zoom options appear.
Okay. Let's see. I think we want to see this screen. Are you seeing my screen?
I think there's one more click you need to do.
Okay, give me 1 second.
Not just yet. There we go.
Okay, so you're seeing the full pre-applied waterproofing system screen?
Yep.
Okay, so I'll keep my camera off too, just in case.
And Peter's rejoined us as well on microphone, so he may be able to comment as well.
Okay, perfect.
Over and
yeah, so-
I'll try to moderate if that makes.
Okay, so we're going to talk about drainage composite boards a bit. They can be used to help improve the profile of the shoring substrate, such as secant piles or sheet piles, or even a wood lag-in or any type of uneven substrate. It's really a low-cost, highly effective substrate preparation system. And if it's a non-hydrostatic condition, it's actually quite valuable in terms of moving the water away from the building structure. So if you have a site, if you have site water or you have a high perched water table with water coming into contact directly with the drainage composite board, it's actually going to assist with the water management system by collecting the water and carrying that into a base drain, which you can then move away from the building structure with a pumping system. So drainage boards can become your first line of defense in managing water around your building and reducing the pressure on the vertical waterproofing system, which minimizes sort of the overall risk to the structure as well. And that was, Peter just discussed quite a high level discussion of some of these design considerations. So after you've selected the best possible system for your project, you're going to have to turn it over now to a contractor. And that's when some of these installation details and specification criteria will come into effect. Whenever you're detailing pre-applied waterproofing, you need to think about how to minimize the risk for the installer and eventually the owner as well. So if you look at the image on the left-hand side, you've got these pile cap conditions. It's a very difficult, congested space. It's going to require a lot of detailing and a lot of labor to complete this job properly. So as the installer, selecting a membrane for this sort of a challenging area, it means they're typically going to have to use a smaller width roll or of pre-applied waterproofing, because he's not going to want to use larger rolls or wider rolls, because he's going to have to do a lot of cutting. It's going to create a lot of waste, and they can splice it, but it just creates too much waste for them. So on a job like this, the foreman's probably going to have his best mechanics working on these details, because they are extremely challenging and it's going to be very time consuming for him as well. Now, as a comparison, on the right-hand side, you've got a mud slab application. You've got much wider rolls being applied. And, it almost looks like the perfect dream job for an installer. Maybe a good architectural specification or good details is what actually created this situation to make this job go much smoother. So if you can look at the site, the drawings, the details, understand how that installer is going to actually subdivide that site into various levels of difficulty, then you may be able to address the areas of concern before they even happen. And just as you see on the left-hand side. So if you can detail suitable substrates for the membrane application, and I think just a quick plug for manufacturers like ourselves, that's where we can help you visualize your details from an installer's perspective and really help make your jobs go much smoother and risk-free as possible. Now, prior to the application of waterproofing, there may be a need to fill some voids between the wood lagging. In this case, the installer is measuring a 12.5 millimeter gap. And keep in mind that most of the membranes out there will span that gap. There's a number of mastics and sealants that each manufacturer has that can be used to fill those type of voids. The membrane is a pretty incredible solution to keeping water out of the building. But just like the building structure itself, it's only as good as the foundation, right? So if you have a good solid substrate on which to apply your pre-applied waterproofing, you will have a much better job. It's not really feasible to do all that detailing sometimes just using mastics and sealants, it's quite laborious. So the next step would be to use a drainage board, or maybe even plywood, a marine grade type plywood. Or you could even apply a low-rise spray foam to create a smooth substrate for the pre-applied waterproofing. So the next slide we have sort of demonstrates a very challenging, difficult substrate. And you can see that, you know, trying to apply a pre-applied waterproofing over such a very challenging surface on the left-hand side would be not only almost impossible, but very costly as well to provide a proper substrate. So if the installer had to try and get that waterproofing membrane to contour around all those projections and penetrations, you know, whether it's a plastic, a rubber, or mineral-based technology, the risk increases dramatically for potential water bypassing or breaching the entire system. Now, this is sort of a before-after picture. So the after picture on the right shows just by using some low-rise foam, you achieve a smooth, relatively smooth substrate for the pre-applied waterproofing application. And it allows your mechanical, it allows you to mechanically attach the membrane at the very top as well, and fasten it to the foam. Here's another critical detail to point out, that each manufacturer may have, you know, they may have different overlap and end lap requirements in their instructions. So for instance, the plan view on the left-hand side of it's a under slab application. It indicates that the overlap and the end lap conditions really can vary from 50 to 100 millimeters depending on the material. So understanding what the manufacturer's recommendations are for end laps as well as for overlaps will determine how many seams you're eventually going to have on that project. And not all the job sites are going to be as wide open as the image on the right-hand side. I mean, if you think back to the earlier photo that Peter showed where you had the congested, or sorry, I showed you that photo where the pile caps were. Think about how detailing around those pile caps, how many more seams will be added to the project. You need to be aware of that because there's different types of tapes, there's different heat welders and equipment that's necessary, you know, along with the different overlaps and fasteners. And these can all sort of prove to be problematic at a later date. Now, this is a manufacturer's selvage detail with the top detail, you know, on the left-hand side. You may only have one selvage available coming into contact with the smooth underside of the adjacent sheet. And that had to be cut, and there's a tape that's used to seal the seam at the very top. And with the detail below that, you have the manufactured selvage tying into another factory selvage. And there's no need for any additional materials between the seam. And whether the manufacturers decide to use an acrylic or butyl-based adhesive, you'll always get a very strong bond. So working with the manufacturer at the very start, you can help you identify what type of detailing solutions their membranes require. And if it's not a tape solution, then what other types of adhesives are used between the overlaps and the end laps. And I think Peter's red arrow here, if you may want to discuss it, Pete, I think you're just showing that you've got one overlap over the other with the selvage seam.
Yeah, that's just to draw attention to the lap there.
Okay. Here's a very often overlooked detail on projects, and that's where you have that wall slab transition. Looking at this image, you'll see it's a very wide roll that begins on the wall with the cement board backing, and then it turns down 90 degrees onto the mud slab, and it's all one wide sheet. So when you have a membrane that's available in wider formats, you have just reduced a considerable amount of risk at that really critical transition detail. And if you look further down the wall to where some of the wood is located, it's about 20 meters away. Then that's the next point at where a seam is going to be required. So you've reduced the number of seams in this critical area, because oftentimes on a job site, you'll have site water ponding, you'll have high I tried hydrostatic conditions, and more often than not, this transition area on the job, it's usually not this wide open. It's usually not this very clean, very congested area. Usually, sometimes confined, damp problem areas to work with for an installer to work in. So if you can reduce your risk by minimizing the number of seams, it's going to ensure a better long-term performance of your system.
I would add that that's the lowest point in the excavation, therefore the most.
Yeah, that's correct. The most acceptable to hydrostatic conditions. Sorry, Peter, I didn't mean to finish your sentence there, but I think you cut off. Inside corners are another very important, often overlooked detail. Not all job sites are going to be completely square, but even if they have a 90-degree angle detail in that particular corner, it's still very important to ensure that the wall slab transition is adequately protected and continuous. And as you can see in the image, an inside corner area, there's a couple of ways you can do this. The images on the left, the details, are just one example of how a skilled mechanic would actually achieve this corner detail. So you might have heard the terms in the past or on site. You may hear terms such as dog ears or pig ears from installers. It generally means the same thing, and it's often used to create these kind of corner conditions. And there's some manufacturers that provide prefabricated corners for these areas to help ensure water tightness. If the installer is well trained and working with flexible, sort of high performance waterproofing membranes, then the corner can be addressed without the need for additional pre-manufactured materials as well. Now, similar to an inside corner, you've got the challenge of an outside corner detail. And most outside corner details are not going to look like this image here specifically, because here we've got a built-up condition where you have a sort of extruded polystyrene insulation that's inside a grade beam. And you can see where they've used tape to facilitate the bend or coverage around that angled piece. Now, when you look at detail number 1, you can actually see there's a 90-degree cut. And then in detail 2, there's a dark gray target sheet that's been cut away and wedged underneath the overlap with some sealant at the corner. Now, moving to detail 3, that's where you use a tape system as an example, and they've just taped over those 2 seams. Detail 4 is a really great detail where the finishing technique by the installer, could be applied to several different types of conditions throughout the project. Pipe penetrations, whether it would be under slab conditions or through vertical walls, you do require critical detailing components, which is typically a sealant or adhesive type of solution. When they're covering it with a tape, for instance, it does ensure very high performance detailing. So depending again on the manufacturers you work with, the tape systems, whether it's butyl or acrylic, or even a hybrid type tape system, how well those tapes bond are very important considerations for choosing the right products. And of course, the use of water stops that are shown wrapped around the pipes that Pete had shown earlier in some photos, they're going to become bond breakers, and you're going to be pouring concrete against it. So whether you use a swellable or a non-swellable type system, it is your choice. Just keep in mind the water stops are extra forms of waterproofing protection, and at predetermined penetrations. Here's the vertical application, very similar detail. You could utilize the sealants, the adhesives, or the water stops to protect the critical point through that wall penetration. And I think it's important to remember that whether you're using an active or passive type technology, each manufacturer is going to have their own detailing compounds as well as their own water stops. So making sure you have that area addressed will ultimately ensure that you have better long-term performance if you choose manufacturers that have the full array of materials to cover all these critical details. Another critical area, you've got a cluster of different pipe penetrations. And in an ideal world, if during the pre-installation meeting, the installer can ask the general contractor to just keep those pipes 150 millimeters apart, it's going to be a very successful application because they can seal around those pipes properly. But we all know that schedules are very important to general contractors, and making any types of changes to pipe placements is often going to get pushed back. So solutions for these types of penetrations have to be developed between the manufacturer and the installers. And it's often where we use pipe banks or metal pitch pans, or utilizing some type of a self-leveling or multi-part detailing compounds. And those tend to be the best solutions that we can create. So again, understanding which manufacturers have those type of capabilities and providing those types of solutions, whether they're, even if they're multiple solutions, it's going to have to help you decide which is the best application for your project. We talked about pile caps a little bit, and there are several conditions where pile caps are going to arise. Some are going to be depressed, some are going to be elevated, and some are going to be flat. And I don't want to offend any structural engineers on the call, but every manufacturer would prefer to install their pre-applied waterproofing right over top of these pile caps. It just makes it easier for the installer and to form a continuous monolithic waterproofing system. But most of the time, the structural engineers are not going to give permission to install a pre-applied waterproofing over top because, again, it creates that bond breaker. So depending upon the condition and whether or not there's the ability to detail on top of the pile cap, they may be able to just create a collar detail on the side of the cap instead. These are all things where you want to make sure the detail does take into account any structural concerns on the project. Sometimes if it's not a high profile building, with a lot of structural considerations, the structural engineers will allow the installer to go right over top. It may even be possible to transition from say a fluid applied waterproofing system over top of the pile cap and then transition back to the pre-applied waterproofing. These are all details that can be worked out with manufacturers prior to the actual start of the job to make it easier. Then with shoring methods, you do add tension into the system, and they have to be removed at some point in time. And these are very common occurrences, and as you see it with this tieback application. So most manufacturers have prefabricated covers to go over top, as shown in the detail on the left. Really, in this case, it's just a metal box going over the top, but you've got round containers as well. They're all different types of shapes. Some manufacturers offer prefabricated plastic molds, specifically designed to cover soldier pile tiebacks. So where plastic tieback covers are not available, sometimes a simple metal box cover can be crafted to suit the project specific need, depending on the skill level of the installers. And as you work on a project, starting from the ground and working your way up the wall, there may be transitions between different waterproofing systems at the footings or even at a plaza deck as detailed here. So these transition areas could be between the same waterproofing manufacturer, and it may involve one or two other installers going from one type of technology to another. Having that support from the design stage on job specific detailing is going to be one of the more important attributes that you should be looking for in a manufacturer. And of course, I can't stress the importance of a pre-construction site meeting with all of the parties involved and present. Not all the standard conditions are going to cover what you need on a specific project. Most manufacturers are going to offer their details online, such as we do at cahenry.com, and they can typically help you review custom details as well. For project managers who have to deal with, what was drawn versus what was actually constructed, we're always available to help you decipher those details and confirm that water ingress is not going to occur at a particular transition detail. Now, there are other things that need to be factored in, chemical compatibility, obviously. Some materials are just not compatible. And as an example, say a coal tar and certain other products don't mesh very well with some pre-applied materials. So you have to make sure that you've got the right solution and get the manufacturer's involvement to help you recommend those proper details at these critical junctions. And as you start developing your design, really you need to start thinking about long-term accountability for the system itself. And that's for you and your client's needs. There's a couple of ways of looking at this. So warranties, if you think about warranties in your own personal experiences, whether it's from your car or your computer or your phone, what do these warranties really offer you? And most of the time, the first type is a material warranty. And this is sort of your proof of purchase. Then the second type is a workmanship warranty, which includes both labor and material coverage. The standard period for this type of material, pre-applied waterproofing, runs from 10 to 20 years. And you may even have a customized warranty in your specifications that you can even introduce as well with different manufacturers. So when you think about waterproofing, most manufacturers are going to be accountable for labor and material coverage, right? I mean, that should sort of give you enough confidence that the manufacturer believes in their product, they understand its limitations, such as knowing how their systems will perform in harsh environments. They have trained and approved installers who know how to install and detail the materials correctly. And there may be a small warranty fee charged to the owner, or they may have already built it into the material cost itself. But keep this in mind, the manufacturers do have a plan of action if there is any water ingress within the building structure. Now, I know you've heard this saying before, there are some warranties that are not worth the paper they're written on. And it really is true. Then there are some that will sort of promise to cover everything for the maximum period possible. And they sound like the best warranties out there that have been ever written until a leak actually occurs and your client starts to redefine print and finds that there's a loophole. So I hope you don't ever have a client pay for a high-end warranty only to find out that the vast majority of the repair cost will be coming out of their pocket. And there are what, sort of value-based warranties, which are reasonably priced, sometimes even free. So it's important as designers to really understand that every manufacturer has a different warranty program, and it's sort of up to you to choose the best solution for your client. So, this is where you need to work with the manufacturers, determine what type of coverage their warranties will offer, and really do a thorough evaluation of the programs. And by all means, I'm sure for the architects and engineers listening in, I'm sure you have this covered in your specifications, but by all means, request a copy of that warranty specific to your project and based on your specifications for review before the job even begins. If you do nothing else, except request a copy of the manufacturer's warranty and make sure it's specific to your project. I mean, if you would ask, give you an example. I mean, if you'd ask the clerk at Best Buy, what am I getting in the extended warranty for my new laptop? So if you owe it, you kind of owe it to your clients. So you get a copy of it. And if you don't have the time, send it to the manufacturers for review, because material warranties, are the basic of all, and they're often misunderstood. A lot of material warranties may make clients believe that it's this sort of basic warranty is really going to cover them for water ingress. But keep in mind, most material warranties are for defective products only, which means material has to be validated to be manufactured out of specification tolerance. These types of warranties make no reference at all to water ingress. It just covers the product if it's defective. So this is where, again, doing a lot of work and research on warranty options from all the various manufacturers is going to be important on selecting who you work with in the future. And there's another way of looking at this. And this would be what we would call investing into the project quality assurance programs. And think about it this way: how do you prevent a warranty discussion from even occurring? And that's where manufacturers can provide guidance as well, because this is where an authorized contractor programs and authorized inspection firms work in conjunction with the general contractor to support best practices, such as pre-construction meetings, and then preparing inspection reports that are shared with all the relative parties. And most manufacturers have a quality insurance type approach. So when we recommend that your specification is broad enough to cover all the different types of quality assurance tools and help ensure that you get the best warranty and the best quality program for your particular project. Let's review the authorized contractor program. When manufacturers are going to have their requirements, such as you have to use one of their authorized contractors. How did that manufacturer actually determine that this installer was an authorized contractor? What type of track record does this contractor have in order to be considered authorized? Is there some sort of a training program in place by the manufacturer, or does the manufacturer just write a letter of approval and then approve the lowest bidder because they just want this job? And having said that, most reputable manufacturers do have an authorized contractor program in place, a warranty responsible approach as well. So it's ultimately going to be responsible for remediation, and let me back up on that. So who's really responsible for remediation on this? If there's an issue on site, is it going to be the manufacturer or the contractor? So unfortunately, what you have is that contractors sometimes go out of business, right? And then a warranty is supported by the contractor or the manufacturer. Typically, it's going to fall to the manufacturer to evaluate and pick up the pieces. So that's important to figure out who you're going to work with at the end. And another part of the quality control is the authorized inspection firms. They may be consultant engineers or building science specialists, and their only function is finding solutions to keeping the water out of the buildings. They should be contracted with the owner to provide on-site evaluation and provide reports to the owner, validating what has been done correctly by the installer, recording any deficiencies, and ensuring that they've been corrected, making sure all sequencing is being done properly, and identifying any locations where damage to the membrane may have taken place by third-party contractors. The authorized inspection firm is required by the owner to help coordinate this specific part of the project when the waterproofing manufacturer is not available on site. They have to become a very important tool that a lot of manufacturers have started moving towards in the last 10 to 15 years. And really what this program does is act as an additional set of eyes and ears on the job site. And of course, it helps mitigate their risk as well. And I'm sure you're all familiar with the pre-construction meeting, where all the stakeholders on the project, such as the owner, the architects, engineers, they're all going to participate with a focused understanding on doing the best quality work to create a very watertight structure within the construction schedule that will make everyone happy, right? So what will it take from each respective trade? So it's a clearly delineated program. The general contractor is ultimately responsible for his substrades. The waterproofing contractor has to provide the installation. The inspector has to validate that the installation has begun on a proper substrate, that it's been installed correctly, and make sure that it doesn't have any damage after it's been installed. And there's a series of other reports and checklists that all make sure that the waterproofing gets installed properly. And here's an example of the inspection report itself. So this is going to be sent to the entire construction team. They're provided quickly, so everyone is given a very short window to make changes or course corrections prior to concrete placement. If you think about it, once the concrete is poured, it's going to be incredibly difficult and costly to remove, which doesn't happen very often. So if you can avoid remedial work by getting information to the key people that need to make the decision, that's going to ensure that the product and the waterproofing get installed with the details addressed before they can even become a problem or delay the work in progress. And again, that's where manufacturers like ourselves will actually store all this information. We'll help work with the general contractor, the waterproofing contractor, the architects, the inspection firms. We'll coordinate all of these different parties and keep track of all these reports and any changes that may take place. Because when the time arrives for a warranty issue, we will be ready to make sure everything's been covered. As an example of an action item tracking list, and one of the more overlooked pieces of these types of lists is the water stops, because as Peter mentioned earlier, they're kind of out of sight, out of mind, and a secondary form of waterproofing protection. So usually the waterproofing contractor would be the sub-trade that actually installs the water stop. But sometimes water stops will fall under Division 3. So at a pre-construction meeting, it's important to understand who's actually going to install that water stop. And that way, if there's a separate subcontractor under Division 3 that's installing the water stops, a general contractor has to notify them that this form needs to be completed, certifying that they supplied and correctly installed all of the water stops on the project. And they also have to provide a summary to the inspector for any of these action item track lists. And last but certainly not least, you have the manufacturer's warranty requirement checklist. And this includes everything we've just discussed. So, did the pre-installation meeting take place? Were there any changes? How was the pre-applied waterproofing installed? How was it done properly? Have all the forms and construction inspection reports, everything we just saw, have they all been submitted? Have all action items been checked off? So really, the manufacturer plays a very important role in this and make sure that all the records for the overall project have been evaluated and managed before a warranty even comes into discussion. And to summarize, the pre-applied waterproofing system will be installed on the positive side prior to the foundation and under slab application. You want to select a membrane that's suitable for horizontal as well as vertical applications. And wherever possible, you want to make sure that the substrate is protected from frost or stand-in water prior to the actual application of the waterproofing material. A pre-applied waterproofing is inherently associated with zero lot lines and for underslab applications. So if you make sure from the very beginning that you've chosen a pre-applied waterproofing that can work in all of these areas that we've shown you here today, then you're going to ensure that your building is going to be watertight. And when you look at the overall system itself, you've really got 6 different components that you need to look at during the design stages. And if you focus on these, one being the condition of the concrete substrate itself, the selection of the waterproofing membrane, how do you treat the seams, whether it's a tape, a torch, or sort of heat welded application. Do you need drainage composite boards? Do you have the proper sealants and mastics for all the detailing? And finally, are you going to be installing secondary waterproofing systems such as the water stop solution? So you have a couple of options to select from and specify for each one of these different components. And that's where, our experience, Peter's, myself, and Renee, who's also on the call, will come into play, because we can help the architects, the consultants, and installers on waterproofing projects almost every day. That's our job. So we share our experiences through the installer's eyes as well, to sort of give you a different perspective on where those critical areas there are, where they're going to divide the project into difficult and easy areas, so we can kind of help you with those critical details. And we can also review the geotechnical reports on your behalf at the very early stages to determine if pre-applied waterproofing is even required. Now, from a design standpoint, making sure you design and specify the waterproofing system that meets the needs of the site requirements. Anticipate the substrate conditions. There could be different types of soil retention systems. Consider Substrate preparation, I mean, you may not have a mud slab, or it may not be allowed because of cost restraints. So the membrane selected has to be installed directly on compacted soil or a granular base type material instead. There's also environmental considerations. Is there a radon gas situation on the site? Maybe you might have a high perched water table every 15 years that's going to raise the hydrostatic pressure to new heights. Has the site been properly evaluated by geotechnical reports, and all those design considerations in mind? So, most architectural firms understand all of these parameters of pre-applied waterproofing. It's going to be irreplaceable to a building owner because they can save them a lot of remediation work from, crack injection waterproofing down the road with these early discussions with the manufacturers. We saved the final slide in the deck to kind of quickly touch on quality control. And as I mentioned earlier, you have to invest your time and effort in the project to make certain that not only is the right pre-applied waterproofing material used, but that your building becomes completely watertight, because you can't go back once you've installed this product. It's very difficult. So just have a better understanding of your warranty requirements as well. You've specified a third-party evaluation team, making sure that everyone is doing their job and the installer is doing what they're expected to do as well. If you've minimized any potential compatibility concerns at transition areas between dissimilar materials or sealants, then this job is going to be very successful for you. And the goal of any good waterproofing manufacturer is to assist you along the way to help you reach a common goal, and that is, of course, to reduce the risk of water ingress on behalf of your clients. And that concludes the continuing education presentation. I know we've went through a lot of information, that may have brought on some questions. So, Peter, I don't know if you've addressed any questions in the chat lines or the question lines. This might be a good time to recap, but otherwise, please, if you can unmute your mics and ask any questions you may still have, we would love to answer them.
So I'm going to jump in there, Roger. The attendees, oh, sorry, I shouldn't have had that turned on. Breaking my own rules there. The attendees do not have the ability to unmute themselves. This is a webinar.
Thank you.
So we have asked that attendees post the questions in the Q&A or the chat if possible.
Okay, that's fantastic. Okay, so there are no current questions in the Q&A. I'm not sure if there's anyone typing. It looks like there might be. I'm not. Oh, there's a couple.
We're getting a few through the chat there for you.
Right. Okay. Okay, so a couple of questions. Can we apply for the AIA or CES credits? If you are an AIA member, we do have the approval. So if you would please send your contact information to a Henry representative. I believe Renee would be the person to contact here, or you can send to Peter and I as well. That's fine, and we'll make sure that you get your accreditation. Can we get an online version to review later? Yeah, by all means. I mean, if you want to email us and let us know what exactly you're looking for, if it's just a PDF file, I'm sure we'll be able to accommodate you there as well.
Roger,
Sorry, Peter, you cut off on us there. I'm not, maybe you want to type it into the chat line if you can. Yeah, and as the note says, please, in the chat line, Renee is actually in our virtual show booth. So please, by all means, reach out to him after this presentation.
Yeah, I'll just chime in there for all of the attendees joining us today. When you return to the virtual event site, be sure to stop by the virtual exhibits area. The Henry booth has Renee is there. You can reach out by email. You can connect with the Henry team. They've got all sorts of great information. Probably some additional information that was covered on this presentation here today available there in the virtual booth as well.
So to Laura, who's asking us just to repeat that accreditation information, if you are an OAA member, we can get you a letter of attendance. If you are an AIA member, it requires you to fill out a form. So please contact Renee, and then we can discuss that with you. with that, if there are no further questions, please visit our booth. Renee would be more than happy to answer any further questions or discuss any details that you may have. And thank you very much for your time.
Yes, thanks again, guys. Thanks attendees for joining us today. The next live free seminars will be taking place at 1:30. So in the meantime, we do ask that you take some time to visit the virtual exhibits, see what some of the great suppliers have to offer. You can also connect with other attendees and exhibitors and suppliers of the Merkley Virtual Show through the networking area. And we'll see you back here shortly.
Okay, thank you.